Students, welcome to once again for the session. So we have discussed case 1, that is how we can find out the solution of a system of linear equations in two variables and in two equations, right? Number of equations are 2 and number of variables are 2. In fact, number of equations and number of variables must be equal to use the Cramer's rule. So the case which we have discussed must contain two equations and two variables. And we have solved some examples based on Cramer's rule. Now after that we will discuss a system of three linear equations in three variables. I just tell you, when I started this session, I had given you the basic idea of a system of equations in three variables. System of three equations in three variables. But before proceeding to the system of three equations in three variables, I have given you the idea how to solve a system of two equations in two variables. Now I hope you all people will understand the concept because it's very simple, right? So now we can proceed the same approach, same technique for a system of three linear equations in three variables. Here the difference is what? We will have three variables x, y and z. In earlier cases we were having only two variables x and y. So naturally, if we are having three variables x, y and z, so the number of equations will be also 3. So consider the system of three equations in three variables x, y and z. You have already seen this. a1x plus b1y plus c1 is equals to d1, a2x plus b2y plus c2 is equals to d2, and a3x plus b3y plus c3z is equals to d3. Here x, y, z are the variables a1, b1, c1, d1, a2, b2, c2, d2, a3, b3, c3, d3. They all are the constants, are the numbers, right? It's like this: twice of x plus 3y plus 5 times of z is equals to, for example, 11. So this is a linear equation because the power or the degree of all the three variables x and y are 1. So that is why they are considered as linear. Now we will use the same technique as we used in the last case, having two equations in two variables. So what we will do here, we will transform this system of equations into a matrix equation, that is of the type of ax is equals to b, right? A and x and b, they will have the same meaning as they were having in case of two equations. We are not going to change anything, right? A, x and b will have the same meaning as they were having in the last case. A simply represents the matrix of the coefficients of the variables x, y, z in the given equations, right? Matrix of the coefficients of the variables x, y, z in the given equation. This is A, right? X is what? The variables taken into account in the given equations. We are here having three variables x, y and z. So they are represented by x, and b, as usual, the constant terms at the right hand side, that is d1, d2 and d3. Right? So how we will calculate A? You know, A is the matrix of the coefficients of the variables in the given equation. Say here in equation number 1, the coefficient of x is a1, so a1 is here. Coefficient of y is b1, b1 is here. Coefficient of z is c1, c1 is here. Clear? This is all for the first equation. We are getting the first row of our matrix A. Now take second row. Coefficient of x in the second row is a2. We are having here a2. Coefficient of y is b2. We are having here b2. Coefficient of z is c2. We are having here c2. And finally, in the third equation, coefficient of x is a3. So we are having here a3. Coefficient of y is b3. So we are having here b3. And coefficient of z is c3. So we are having here c3. Right? This is how we can write down the matrix of the coefficients of the variables x, y, and z in the given equation, right? Now, if ax is equals to b has been written, if we have written ax is equals to b, and what we did next, a is this, x is this, and b is this, the solution of the above system of equations is given by x is equals to dx divided by d. As usual, x is dx divided by d, y is dy divided by d, and z is dz divided by d. What is d? D is what? D is equals to the matrix what we obtained from the given equation. Write down its determinant. So D simply represents the determinant of the matrix A, right? This is your D. As usual, verbatim, dxc. How we will obtain dx? We will use the same technique to find out dx. The first column of D, see this. Let me explain once more. The first column of D, this column of D should be replaced by the right hand side D1, D2, D3. Second and third column will remain as it is. See, D1, D2, D3, second and third column will remain unchanged. This is how we can get dx. Now, to find out dy, dy means the second column of D, means B1, B2, B3. The second column of D, that is this one, should be changed by the same term, that is D1, D2 and D3. See, the first column of D and dy same, third column of D and dy is same. The second column should be replaced by D1, D2, D3 to get dy. And likewise D3, first column and second column of the determinant D will remain as it is, and the third column of D should be replaced by D1, D2 and D3. So we have used the verbatim approach as we used in case of two equations, and then D is there, dx is there, dy is there, dz is there. Put the values to find out the values of x, y and z, right? Now let us understand the concept by a practical case or practical example. Solve the following system of equations by Cramer's rule. Let us have this case. This is equation 1, this is equation 2, this is equation 3, right? X, Y, Z, they are the three variables. So solution of this system of equations means find out the values of the variables X, Y, Z, which must satisfy all the three equations simultaneously, right? So this is our system, right? The first step is what? The first step, transform this system into the matrix equation AX is equals to B, right? The above system of equations can be written in matrix form as follows. AX is equals to B, where what is A? See here, write down A here. I am explaining this as the first case of three variables. A is what? A is simply matrix of the coefficients of the variables x, y and z, right? See the first equation. Coefficient of x here is 1. Coefficient of y is 1, coefficient of z is 1. So what we are getting? 1, 1, 1, right? 1, 1, 1. Now take equation 2. Coefficient of x is 2, coefficient of y is 3, coefficient of z is 4. So 2, 3, 4, right? Third equation, coefficient of x is 1, coefficient of y is 2, coefficient of z is minus 4. So 1, 2, minus 4. Right? X is as usual, three variables, x, y, z. B is as usual, the terms at the right hand side. Right? Clear? Now use the same approach. What we will do? We will first find out the determinant of the given matrix. That is, determinant of A is denoted by D. So this determinant is given by C. I think its value is coming out to be minus 7. See, students, determinant is very essential to understand this session. If you are not good in determinant, it would have been very difficult for you to understand. So determinant, I had already explained each and everything. So you should practice yourself to be comfortable or efficient in finding out the determinants of the various order. So the value of this is what? Take this, expand it along the first row. 1 is this. Delete the row and column in which 1 lies. So 3, 4, 2, minus 4, the first. Minus 1. Delete the row and column in which this lies. So this row and this column. What is left? This is left now. 2, 1, 4, minus 4. 2, 1, 4, minus 4. We are getting this. Now come to 3. This one, right? Delete the row, this row and this column. 2, 3, 1, 2. 2, 3, 1, 2. Now simplify all these three. Calculate them. You will get minus 7 as the determinant of the given matrix, right? Now, if D is there, now you know how we can find out dx. See, write down D here. What is D? Then I will show you how we can find out dx. D is equals to what? D is 1, 2, 1, 1, 3, 2, 1, 4, minus 4. This is our D, right? Now determine dx. Oh, sorry. Dx. How we will determine dx? To determine dx, what you have to do, the first column of D should be replaced by the entries at the right hand side of the given equation. See here, the entries at the right hand side of the equation are what? 3, 9, 7. So the first column of D should be replaced by 3, 9 and 7. See here. 3 dx is what? 3, 9 and minus 1. Second column as it is, third column as it is. Now simplify it. You will get this is again coming out to be 7. Likewise, to find out dy, are you getting the point? To find out dx, the first column of the determinant D should be replaced by the constant terms at the right hand side, and the constant terms at the right hand side are 3, 9 and minus 1. So this is our first column which has been transformed or changed. Now to find out dy, the first and second column will remain as it is. We will change the second column of the determinant A by the terms at the right hand side of the given equations, that is 3, 9 and minus 1. So this is our dy. Simplify it. Expand this determinant along any row or any column. You will get its value again 7. Now dz, the first and second column of D will remain as it is. The third column of the determinant should be replaced by the terms which are lying at the right hand side of the given equations, that is 3, 9 and minus 1. So this is our dz, and simplify it again. It is also coming out to be minus 7. So dx is minus 7, dy is minus 7, dz is minus 7, and d is also coming out to be 7. Therefore, by the Cramer's rule, x is equals to what? Dx divided by d, that is minus 7 divided by minus 7, this is equals to 1. Y is what? Dy divided by d, this is also minus 7 divided by minus 7, this is also 1. And z is what? Dz is equals to d, and this is also minus 7 divided by minus 7, 1. So x, y, z, they all are 1, 1, 1 is considered as the solution of the given system of 3 linear equations in 3 variables. Now, I have given you the examples of both of these two categories. One, a system which contains 2 variables and 2 equations, case 1. Case 2, a system which contains 3 equations and 3 variables. And you also observe that the approach are the technique for finding out the solution in both the cases is verbatim. They are almost same. Now, before proceeding further, let us discuss the conditions for consistency. Consistency means, I have told you in the very beginning, whenever we are having a system of equations, it may consistent or it may inconsistent. Consistent means it has a solution. Inconsistent means it has no solution. So what we are doing now, we will discuss the conditions for consistency. Conditions for consistency means under what conditions the system of equations will be consistent, means it will have a solution, or inconsistent means it will have no solution. So we will discuss two separate cases. One, ax is equals to b, which is called as non-homogeneous, right? Second is ax is equals to 0, which is called as homogeneous. Right? And this is what we discussed in the very beginning. The system ax is equals to b is non-homogeneous, right? Non-homogeneous. And if b is equals to 0, then it converts to ax is equals to 0, then it is called homogeneous, right? So what does it mean? Ax is equals to b itself is known as non-homogeneous system of linear equations if the right hand side, that is b, is identically 0, means all the terms in the right hand side of any system of equations are identically 0, then the system is called homogeneous. So let us take first condition of if the system of linear equations ax is equals to b, means the system is non-homogeneous, NH, right? NH means non-homogeneous. Condition 1, what we did, we calculate the matrix A and then its determinant, right? So there are two possibilities. Whenever we will calculate the determinant of any matrix, determinant may be 0, and condition 2, determinant may be not equals to 0. Clear? Whenever you will find out the value of any determinant, you are getting two possibilities. Either the value of the determinant will become 0 or the value of determinant will become non-zero. So these two conditions are discussed with these two situations, whether determinant is 0 or non-zero, right? Condition 1, if determinant of A is equals to non-zero, then the system is said to be consistent, right? And it has a unique solution given by x is equals to d1 upon d and y is equals to d2 upon d. So in all the exercise which we already solved, we were having this case. In all the questions, the determinant of A was getting different from 0. That is why we always getting a unique solution. Unique means only one, right? The system is having a unique solution means only one. So if determinant of A is not equals to 0, then the system is said to be consistent and it will have a unique solution, and its solution is given by x is equals to d1 upon d and y is equals to d2 upon d. In all earlier examples, we use this condition. Case 2, if determinant of A is identically 0, right? If determinant of A becomes 0, then what we will do? If determinant of A is equals to 0, then we will calculate dx, dy and dz, right? If dx is equals to dy, dy is equals to dz and dz equals to 0, means determinant of A is 0, dx is 0, dy is 0 and dz is 0, then the system is still consistent and it will have infinite many solutions. So this is the case of unique This is the case of infinite. And case 3 is what? If determinant of A is equals to 0 and dx, dy, dz, out of all these three, any one of them is non-zero, right? Either d1 is non-zero, or either dx is non-zero, or dy is non-zero, or dz is non-zero. Out of these three, if any one of them is non-zero, then the system is inconsistent and it will have no solution, right? Then the system will be inconsistent and it will have no solution. So this is the description or the conditions for consistency if the system AX is equals to B is non-homogeneous. Clear? Determinant of A is not equals to 0. A unique solution given by X is equals to D1 upon D, Y is equals to D2 upon D. Determinant of A is 0 and all dx, dy and dz also 0, then the system is still consistent and it will have infinite solutions. And case 3, determinant of A is 0 and any one of the three dx, dy and dz is non-zero, any one of them, then the system is inconsistent and it will have no solution. This is the requirement for a non-homogeneous system of linear equations. Now likewise, this is the case of the homogeneous, means AX is equals to 0. AX is equals to 0 means when the right hand side, that is B, identically vanishes, B becomes 0, then the system becomes homogeneous. So here what happens, see, if determinant of A is not equals to 0, then the system is consistent and it has a trivial solution. Trivial solution means X is equals to 0, Y is equals to 0, right? Trivial means X and Y both are 0. And if determinant of A is equals to 0, then the system is consistent and it will have infinite many solutions. So these are the two conditions which prevails or which are persist by a homogeneous system of linear equations. Right? So from these two characterizations, a homogeneous system of equation is always consistent. Either it will have a trivial solution or it will have infinite many solutions. But a non-homogeneous system of equations may be consistent as well as inconsistent, right? Now let us see how we can use these conditions to find out the solutions of the various questions. Let us take example 1. Solve the system of equations using Cramer's rule. 2x plus 3y is equals to 0. 2x minus 3y is equals to 0. So look at these two equations carefully. 2x plus 3y is equals to 0 and 2x minus 3y is equals to 0. The terms at the right hand side are all 0. So this system is homogeneous. Clear? So before proceeding the solution, check whether the system is homogeneous or non-homogeneous, because we have the different conditions for both. So here the right hand side, this and this is completely 0, identically 0. Therefore this system is homogeneous. Now we have to find out the solution of this system, and we just know that a system of homogeneous equations always consistent. Always consistent means it will have either a trivial solution, that is x is equals to 0 and y is equals to 0, or it will have infinite many solutions. Let us see what happens with this. This system of two equations, the system of equations can be written as ax is equals to 0, naturally, because here we don't have any term in the right hand side. So ax is equals to 0. A, you know, as usual, matrix of the coefficients of the variables x and y. So what is A here? See, A, the coefficient of x is 2, coefficient of y is 3, so this is 2, 3. In second equation, 2 and minus 3, this is 2 minus 3, right? Now simplify this. What is the value of this? Now determinant of A will be written as 2, 2, 3 minus 3, and this is what? If you simplify it, it is coming out to be minus 12. So this is not equals to 0. 3 to the minus 6 and minus 6 minus 6 minus 6, you will get here minus 12. That is not equals to 0. So what we are getting here, we are getting determinant of A is not equals to 0. So by Cramer's rule, x is equals to dx upon d, that is 0 upon 12, 0 y. So x is equals to 0 and y is equals to 0 means trivial solution, right? As we have seen, the determinant of A is not equals to 0, so it will have a trivial solution. If determinant of A becomes 0, then it will have infinite many solutions. Case 2, let us take this one also. Twice x plus 3y is equals to twice x plus 5y is equals to 3, 4x plus 10y is equals to 7. Now, this is a non-homogeneous system because the terms are there at the right hand side. So this is a non-homogeneous system of equations. So similarly, the system of equation in matrix form is Ax is equals to B. See, what is A? A can be written as matrix of the coefficients of the variables. The coefficient of x is 2, coefficient of y is 5 in the equation 1, and coefficient of x is 4, and coefficient of y is 10 in equation 2. Now, this is, and what is x? X is as usual xy, right? And what is b? B will be your 3 and 7. The rest is as usual, right? Now, what is the value of the determinant of A? Now find out its determinant. Its determinant is coming out to be 20 minus 20, that is 0. Dx is 30 minus 35, that is minus 5, is equals to 0. Thus, the system of equations is inconsistent. If you recall the condition of consistency, if determinant of A is equals to 0, and I have told you any one of the two dx dy or any one of the three dx dy dz is not equals to 0, then the system of equations is inconsistent. Inconsistent means it will have no solution. So here the determinant of A is identically 0, but dx is not equals to 0. Therefore, the system of equations is inconsistent. So students, I think I should stop it here and I will continue the remaining portion of the text in the next lecture. Thank you very much.